Osu, and welcome to Lab 3. So the purpose of the lab is that a star is orbiting a black hole of unknown mass located at the origin. We need to estimate the mass of the black hole. Then, next for part 2, we consider a spaceship launching from a planet orbiting the black hole, and we need to find an initial velocity such that the motion of the spaceship can be so the motion of the spaceship is what we desire it to be, and we desire the motion of the spaceship to not orbit the black hole, but go around the black hole. So some important concepts are the momentum principle. We're going to use that to analyze the motion of many different objects throughout the lab. And similarly, Newton's law of gravitation. We will also use it to analyze the motion of the objects. And these are some of the results we got. Here's the black hole mass, and here are some initial speeds. Let's get started. So first, for experiment part 1, we need to set the initial conditions, like the star mass and our delta t. And second, we need to calculate F net perpendicular, because F net perpendicular in this case would be the gravitational force. So here we analyze the motion of the object in order to get the change in momentum. Here you can see we solve for F net using the change in momentum, and then we proceed to solve for F net parallel, and we know that F net perpendicular will be equal to F net minus F net parallel. So that now that we have F net perpendicular, we can now solve for the mass of the black hole using Newton's law of gravitation. And here you can see since it's an iterative process, I added up this will just continue to add every calculated value of the black hole's mass and put it all in this variable. And then when I printed the mass at the end, I divided it by the number of iterations. And that gives us an accurate average of the black hole's mass. And what does it mean? Well, the rate of change of momentum is really just a measure of how the velocity changes over a given time frame. The net force is based not on motion only, but also the mass of the two objects and their distance between them. So mathematically they're the same number, but they represent different ideas. The net force is more than just motion, I'd say. It also includes the mass of the two objects and the distances, where the rate of change of momentum is really just an analysis of the motion. So net force, you need a little bit more. So experiment part 2, the system will change depend on what object you're observing in that frame of reference, but the black hole will always be the surrounding. And depending on if we're analyzing the spaceship as our system, then the planet will be surrounding, and vice versa. So step 1, resolve all the forces. We need to find all the forces on the planet and find all the forces on the ship so we can predict the motion of the objects. So you can see we do that right here. We find both F nets. So F nets right here and F nets down there. Then we apply update formulas in order to make our objects move. We use this velocity update formula right here, and we also use our position update formula. So we update both values for the planet and the ship. And then finally, we guess and check in order to find our initial velocity. So basically, continue to check different ship speeds until the motion of the planet, or the motion of the spaceship, was what we desired it to be, which was these two values. So what if we wanted the spaceship to orbit the black hole? I wasn't able to derive specific answers, but logically I can say that compared to our original value that we discovered in the previous slide, we need a smaller magnitude of the x component and a larger magnitude of the y component, because with the large magnitude of the x component, the ship will not orbit. It'll just leave the range of the black hole's effect. Similarly, with the y component, we need the y component to be a little bit larger, so that way it gives us a little bit more room to work with. Potential errors, there's rounding inaccuracies. We could have tried longer to get a more accurate result, and we assumed that there were no external forces acting on the system in either experiment. So to conclude, we discovered that we can predict the mass of a black hole based on the motion of the star. We also discovered we can find an initial velocity so that the motion of our spaceship will be as desired. And these were our final results. Thank you.